Alright, so let's get started with the next thing that we're going to talk about here in calculus class, which is the shell method. So, again, we're spinning objects, still doing the solids of revolution, we're still spinning objects, and so we're just looking at a representative slice. This is some function of x, y equals some function of x that we're talking about here. If I were to spin this about the x-axis, our disk method would be spectacular. That's what I was trying to say. It would work very nice. It would be effective, I think, maybe the word I was trying to use. But if I try to spin about the y-axis, it's not going to work so well, because we remember that in order to use the disk method, our slice needs to be perpendicular to the axis of rotation. So if I start rotating around that axis, the y-axis, it's not going to get us the same results, right? We could, I suppose, try to solve this, make it x as a function of y, put my slice that way, but that's a lot of work, and it's more than we really need to do at this particular moment. So we'll use a different method called the shell method. Okay? So here's what we're going to try to do. We're going to try to take this function, y equals x squared, negative x squared plus 4, the area enclosed by it, the y-axis and the x-axis, and we're going to rotate it about the y-axis. And it's the same picture we just had on the other side, and so we know that doing the disk method's not going to work. We could probably solve this, but it's, again, more work than we want to get involved with. So we're going to try to find the volume of this, and the shell method's going to be our method. Let's get rid of that down in the corner. I've got Bob working on the side, keeping track of time, so I don't go over. If you hear the beep, that means I've got a minute left. So with this picture, and to have this covered, so it was a surprise, but I don't. So with this picture, there's my slice. Same function, same slice. I'm going to zero in, going to focus just on one point. Okay? If I take that one point for this point right here, and I rotate it about the y-axis, it's like a circle. I get a circle. Okay? We know how to find the length around this circle. It's called the circumference. Okay? My circumference is 2 pi times the radius. If I suddenly add in the height of this object, I end up with a cylinder. Okay? So picture taking this entire slice right here, this entire blue line, including the red dot, rotating it around, I get the outside edge of a cylinder. You know, take a piece of paper and wrap it around, paper towel wrapper, something like that. Okay? The top is still going to be my circumference. I'm just going to multiply that by my height. So what I'm looking at is the surface area. My surface area is 2 pi r times the height. Okay? So if I get the surface area, I can then multiply it by the thickness, okay, to get the volume of one shell. The volume of one shell is going to be 2 pi r h times delta x. Okay? So that's the basic thing. We start with a circle, start with a point. Point becomes a circle. Circle becomes a cylinder, a shell, if you will. Multiply by the thickness. That gets me the volume of one shell. And then, of course, we're going to integrate to get all of the shells. So particularly, let's go to this problem. Okay? So we said first we need to find the circumference. 2 pi times the radius. The radius is just how far that slice is from my axis of rotation. So no matter where I am, my slice is over here, 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 and the distance from the axis of rotation is just x. It's my x coordinate. If my slice is here, it's 1 away. If it's here, it's 2 away, whatever it happens to be. So my circumference is 2 pi x. Okay? Then we get into the surface area portion of it. Surface area, 2 pi x times the height. Height is just the function. We're just talking about a solid piece, so just the function. And again, turn it into volume. Volume 2 pi x times negative x squared plus 4 times delta x. I want the full volume, so of course I'm going to integrate. So I'm going to integrate 2 pi, constant, so that can go outside the integral, x times negative x squared plus 4. Since we're integrating, we're going to make that a dx. Where are we integrating to? Well, from 0 until negative x squared plus 4 is equal to 0, right here, which is when x is equal to 2. So we're just going to integrate from 0 to 2. Okay? 2 pi, let's make this a little nicer to deal with. Negative x cubed plus 4x dx. We can integrate this easily enough. 2 pi negative x to the 4th over 4 plus 4x squared over 2. And evaluate it at 2 and 0. I'm going to continue on just to do at least one of these full out. I know you could do this from here without my help, but we'll just roll 2 pi. Nice thing, the 0 is going to disappear for us, so that's a nice piece. Negative 2 to the 4th over 4 plus, this is really just 2x squared, so let's make it that. 2 times 2 squared. What do we get here? 2 squared is 4. 4 times 2 is 8. So 8 minus 16 over 4, correct? 2 to the 4th is 16 over 4, so 8 minus 4. Going to multiply that by 2 pi. 8 minus 4 is 4. 4 times 2 is 8. Turns out to be 8 pi. Good? Problem number 1. Check. Okay, shell method. Start with circumference, surface area, volume, integrate to get all of the volumes. Okay, let's look at another. Here we go. So we've got y equals x minus x cubed. That's this guy here between 0 and 1 in the x-axis. So just this region, which I will now attempt to highlight for you. Good. And that's what we're going to rotate. We're going to rotate about the y-axis. So since it's a function of x, there's my little slice. Disk method's not going to work. We're going to have to use the shell method. Forgot to tell you. Shell. Wait for it. Parallel. See how they kind of rhyme? Yeah. So, shell parallel. I think I spelled parallel wrong. Is that better? Let's try that. Shell parallel. So, circumference. 2 pi times x. Right? How far is it from my axis of rotation to the slice? It's x. Surface area, 2 pi x times my function, multiplied by my function. Volume, multiplied by delta x. I'm just going to go right to the general volume statement. So I put it in here, so we'll just keep it. 2 pi x times x minus x cubed. And we know we're going to integrate from 0 to 1 because it was given in the problem. Okay, little more simplification. 2 pi integral from 0 to 1 to x squared minus x to the 4th dx. I think I'm going to let you do this one on your own. It's not that crazy difficult to do, but I think you can get that taken care of. Come up with an answer that would tell you the volume of this thing, and it's really describing what that shape looks like. Think about what it looks like as we rotate that around. It's, I guess, like maybe the top half of a donut or something like that. Take a donut and slice it parallel to the donut hole, or perpendicular to the donut hole. We might get something like that, but that might not be a good example. I'll just move on to the next thing. All right, so here we've got, as a function of y, x is a function of y, between 0 and 1 on the y-axis, and the y-axis. So y-axis, 0 and 1 are there. So this part's not really what we're looking for. What we're focusing in on is this region right there-ish. Okay? So it's x as a function of y. We could, I will let you in on the little secret, we could possibly do this with the disk method, but with a disk method we'd have a slice. We'd have a slice. Where do we have a slice? We'd have a slice right here. So we'd have an integral using this function, then we'd have an integral using this function, and we'd have to solve this, make it y as a function of x. So that's not really what we're gonna be about. So I'm gonna undo both of those lines. Super. X is a function of y, so my little slice is going to go sort of that way. Pretend that's straight. Don't know why I can't make a straight line, but it's late. Okay, it's 3:30 on a Friday. If I rotate this about the x-axis, my slices are parallel to the axis of rotation. So that's telling me to use the shell method. I can use just one integral. I don't have to do, two different rules. So let's set it up. Okay? I rotate through. My distance is, in this case, y. That's how far we are. So in terms of my circumference, I'm going to try to do this in one swoop. 2 pi. Circumference is y. I want it to be x, but it's y. Times the height, which is the actual function itself, times the thickness, and so we're going to integrate, in this case, all of them. Okay, so we start with circumference, then we move on to surface area, and then the last layer is we get volume into the mix. Okay, and the integration gets us the volume of all of those pieces put together. Okay, does that seem to make some sense? You can do this integral. You can do it on the calculator. Again, if you're using the calculator, it'll just when you plug in x's instead of y's, and calculator doesn't really know. It just stands on its side and makes the same thing for you. Okay, so there's that one, and I think that about covers it. Let me see. Did I skip over something? I got through them all. Okay, rotated. Find its volume. Okay, got that one. Got that one. All right. So, again, with the shell method, okay, we start rotating about this. Remember that for the shell method, we want our slice to be parallel, shell parallel. Okay, and hopefully, perhaps by now, you might get the connection between the pictures and the topic. Okay, I should make that a question mark. Get the connection? All right, if you don't get the connection, the convection or whatever that's supposed to say about connection. If you don't get the connection, well, I'll try to give it to you on Monday. Okay, well, no, it'll be Tuesday. Meanwhile, I'll stop talking now because I'm rambling. Thanks for watching. We'll see you tomorrow.